Hello, welcome. My name is Kevin Piccone and I'm the developer of PlayBASIC. Recently, one of our forum members, Kman, he released a game called Operation Watergate 2. He mentioned there was some performance issues with it, and luckily he's included the source code with the demo. So let's load the demo up and we'll have a bit of a sticky nose through how it's running. And I think it's probably buffer related management that's probably the issue, and we'll see how we go. Alright, so I've unzipped the package. I've unzipped Operation Watergate. It does include the code, which is fantastic. Just drag it across to PlayBASIC. Now he's using PlayBASIC 164p and I'm using revision 4 of that. Now hopefully he knows there's more up-to-date versions than the one he's using. But it seems to work fine in this version anyway. Not without saying there are issues. Now I have run this before and I will change something up front. I don't want it changing to full screen exclusive. I just wanted it to run as a window so we can capture the window as we're running it. Let's have a go. Let's run it. F5 to run. It'll do a build and then we're loading. I've just been fiddling around with this before, so a lot of the files will actually be pre-cached by the operating system already. But it still takes a while to load. It's one of those ones where when I first ran the game, I was thinking, oh, has it crashed? Is it doing something? So it needs to have some response back to the user. The smallest thing would make someone comfortable in what it's doing. Right. Okay. There's this weird pause initially. We haven't started playing yet. I'm not quite sure what it's doing. I'm not quite sure the logic behind how it's written. There we go. For those who are old like myself, you might remember Impossible Mission. It's like an isometric version of that. It's a great idea, actually. I can't believe I never thought of it myself. But so clearly we've got some performance issues with our frame rate. But we are running, so that's a good thing. At least it's running. We'll address the performance stuff as we go through. If you focus your attention down here, you'll see it's drawing a bunch of lines there. Now, if you're drawing lines to the screen in particular directly and not locking the buffer between the line drawers, you end up with a lot of lost time in PB requests a lock of the surface, draws the line, unlocks the surface, only for you to go and draw another line and then have to repeat that request of lock, unlock process. Unfortunately, that's very slow in contemporary systems. Whereas it used to be, well, not fantastic, but it used to be a lot easier for those things. I'm thinking when PB was developed, by the way, which is back in the early 2000s. Contemporary video drivers don't really support direct draw. That's the problem. So we have to sort of adjust ourselves to work with how they want to work as opposed to how we want to work. I'll hit escape to break out. Now I kind of know what the problem's going to be, but that load thing, so we follow the logic through. We've got a bunch of setup here. It's got some structures setting up. Object, bot, some sort of global structures here, arrays. It's quite a big one there actually. I'm not quite sure why that needs to be so large. a three-dimensional array for objects. You know, that's oh geez. So 64,000. You've got 8 by 8, so it's 64 times what was it? 22,000 times the size of the object structure plus any sort of bounding of that. That's a lot of memory to soak up in that kind of structure. So all of this here is set up. I don't know how this works. I don't know what this is. They're not documented. I don't know what they're doing. My general advice would be to have this initial font load, and even right at the top. Right, so we would do something like this. We'd go, hey, we're loading, and then we start loading our collection of images there, which are being loaded as effects images. So they're stored in system memory, so they can be easily blended to each other. They can be easily coloured or rotated, but the cost for rendering is slightly slower if they're done with the processor. So 50-50, you know. So here we're doing a bunch of setup work on this image here. I don't know what that is. The city lights image, whatever that is. Changing it, moving it. What I would actually probably do is I probably have a function, right? You know, I don't know. Load message. Sorry. So like message in there, have this in there or something, and function, and then message. Now I can just leave that there if I wanted to, but I probably should move that to the bottom of the code so it's not really visible to me anymore. But then I would have these blocks, the message in here, you know. What are we loading first? We're loading stuff first, loading the fonts first, I think it was. So we've got a sync inside there too, so we're going to do a screen. Oh, we better clear the screen there actually. It's when you start the program, the screen is clear to 0. So if I draw text over the buffer again and then do a refresh, we'll see the existing text. So we don't want that. Just clean up as we go through, you know, like that there. And then we can go, all right, loading fonts or something. Loading fonts. What else are we doing? Doing a bunch of work on some images there. I don't know what that's doing. I have no idea. I was thinking about a palette, was it? Yeah. Sound effects. Loading some more images. Characters. It's not pretty to look at, but when a first-time player is playing our game, I have some indication of what it's doing, and it hasn't died. Let's just try it. Well, the font's loaded very quickly, and we got through that aspect there very quickly. So the part that's taking the most time is another aspect of the loading. So we can actually work out too what part of the loading is causing us this delay. Maybe solve it. Maybe we're doing a blending effect on a video image that we don't need to. I suspect that's probably the case. I don't know because I don't know what those load functions actually do. It's probably worth having a look at though. Let's go back and have a look. We're loading characters. Sorry, I'll just rapidly put that through there. We're loading objects. Yeah, okay. That was room graphics, wasn't it? Room graphics, yeah. Robots. robots, and then we're yeah, I think that's the main part there. So if we go back to load characters, no, we're creating walls. Create walls. We should be able to pick out, you know, what functions are costing us the most at startup, and then cards. I don't know. Do a quick save, do a run. Let's actually find out objects. All the other aspects there loaded very quickly, and they gave us an indication too, hey, this thing's working. So if worst comes to worst, we could go inside the objects piece of code and then set it up so that it was showing us what object it was loading in this case. We may not need to do it here to get to the menu. You know, we might be able to load this stuff after you make a selection and then go to gameplay, and then only load objects that are actually going to be on screen. I think it's probably the best idea in most cases, but it's generally more convenient to do it this way. So loading objects was this loading objects routine. Let's have a bit of a look at that. What are we doing? Yeah, we're loading. Yeah, we are doing that. Sorry, talking to myself. Couple of things in there that I'm always uncomfortable about is, one is that this duplication of complexity, or this expression that's like this. If we just have a thing called file, so we make our file name, and we go, all right, dude, do we exist? In other words, is that file on disk? And if it is, let's load the thing. Now, the only reason I prefer to do that is that if I ever make changes to this expression, I would have had to have made changes to the second expression. It's kind of like, well, what do you need to do that for? Now, I suspect this is spending a lot of time doing this, because we're loading in an image into video memory, setting the mask color, doing a scale of it, copying the image somewhere else, and mirroring the image back. I'm not sure what the performance of mirror image is actually like. My concern there is that if mirror image is using a lot of blitz and single strip blitz to do the flip, to invert the image, then that's actually a potential bottleneck in our program that we might just be able to solve by doing something like this, which might seem weird to people. But so here we've got 200 plus here, all of these things here, we've got like this duplicated complexity. It's okay, I've got this one here. So, right, so we're loading the image here, we're creating a duplicate of it over somewhere else. And what you could do, I don't know if, I should check if this is a real image or not, but we'll just assume that image 999 doesn't exist, right? So we'll load that as an effects image. So we want to do, set the mask color of that. We want to set the scale of that to whatever we require, and then we want to copy from that image to that target, and as well we want to copy, well, we need that to be an effects image, sorry, a video image, which is what I was loading before, we probably should do, I'm not sure that we do, but for the sake of completeness, I'll have like a create image in its place. So we'll go, hey, create image, whatever that was, n plus, sorry, 200 plus n, make it the width and size of this temp, commonly used recycle image we're going to just thrash around all the time. In other words, we want to create an image in video memory that's the same size as the one we just loaded and scaled up after it's been scaled. We want to copy from we want to copy from, sorry, we want to copy from the one that's in system memory into the one that's in video memory, and then do a flip of that. And what you probably could do there, and you probably should do, if you want to do a flip, is do the mirror, on this, is mirror this, mirror image, and then copy it down. Wow, am I confusing people yet? So for the time being, we've got 3 versions in memory, but we don't want to do any pixel level operations on anything that's on video memory, because our system may or may not have fast access to that memory. Contemporary systems generally don't. Older systems had much better drivers than what they have now, because no one supports Director anymore. It's like it's a completely and utterly antiquated solution. Everyone's just gone on to go, let's have DirectX 9, 10, whatever else anyone cares about. That comes with constraints, doesn't it? Just double checking my logic. So we're loading her in, creating the first one, copying the FX image onto the first image of it, doing a mirror of the FX image, and then we're going to copy that to this one. All of that trying to avoid doing something in system in video memory. These would be the same, I'll bet. If these mirror functions here, well, there's a bunch of dot plots there too. I suspect we could, what I would do is, in all seriousness, I would make a function out of this to load an image and then have it produce the 2 scalings or whatever. So you could supply a scaling that you wanted, have it load into a particular source image, and then have the mirror be loaded into a target image as well. So it would save having to do this duplicate sort of stuff here we're doing, because those loops there are the same, as far as I can tell. So the same thing there. What about the scaling? Scaling's the same, so we could just have the same functionality there completely. We're just assuming this image here is the one that's available to us. We don't really care about it. If it's in memory after we finish loading, if we reload over the index, it gets deleted anyway. So this won't solve the speed up problems at load time, but this kind of thing absolutely will. Here, get image status. So I'm not sure what images are loaded into this block here, 200 to 200, but if they're video images and we're doing a copy, or we're making a duplicate of the image for some reason that we want to do, or we're making a grayscale of it for some reason, then we're rendering to it, we're drawing dots over the top of it every second pixel. So one immediate thing you could do is just lock the buffer. And then unlock it at the end of the process. So what's happening now is every time this loop steps through, what have we got? We've got 40, step 2, about 70, so we've got about 110, 70 by 110, so a lot of dots to render. Every time it calls that function, it has to lock the buffer, draw the dot, unlock the buffer from the system, loop back around to do the same thing again. It's really inefficient. In this particular case, you'd be better off to draw an image with the white dots every second color, and then just draw that image onto those. It would be much more efficient. But this is fine. We're loading a lot of stuff into memory in here, so that's okay. We're loading more stuff into video memory, doing more copies of it, and doing scales of it. I think the scaling is okay, but I think that's driver related too. So in general, I would do that process on a temp image and then copy it to a video image that I wanted for my final image. I would use system memory to do the work on, then copy it to video memory when you're done. We'll run it and see if we've broken it. Well, there you go. So I've had something of a win there. Obviously, what I'm talking about is not rubbish. It's you got to think about how this stuff is done underneath the hood, and doing an image flip or those things. So it might be the scale image too. I don't really know. All right. Like for all we know, this part of the loop here might have been the part that was causing the huge slowdown. It might not have been the flipping. We'll just test it and find out. Well, there's a good answer there. I think we have our answer for that particular thing. I still think probably, drawing XY. Sorry, we're drawing the across here, but we're drawing vertical columns. Wow, that's very unusual. You normally don't want to do that because memory is non-consecutive when you do that. You normally want to do this. In this case, there wouldn't be any performance benefit for doing that in PB, but if you unrolled this and took this a bit further and tried to do dot plotting to the buffer directly and then converted that into PB to DLL, then the performance benefit you would get is enormous. But nonetheless. Alright, so we've tweaked the loading, we haven't fixed it. I think we could probably get this to a point where it loads, within the first second and quite comfortably by the looks of those things. I've got some data being read from the end of the program, which is, I guess that's the help files, is it? Yeah. I tend to be a stickler for things like text inside applications. I try to have that externalized as much as possible, and one of the reasons for that is you can update the text outside the program, have other people write the text for you, etc., and possibly, if you wanted to, is have language conversions for those dialogues. Nonetheless, let's go back to the start. We'll tackle the main loop. So we're loading our sounds. That's our opening screen. Let's have a look at that code, subroutine. Setting up volume. Oh, that was one thing I did find a bit strange, is we're doing, it's kind of hard-coded to run from the joystick or the control key, which I find is an unnatural key for me. So initially I had no idea what was happening. Oh, there's another one there. These kind of, if you wanted to have, hang on, what were we doing there? Let's just unroll it. So we're drawing in color 0 in the black version of this text, slightly offset from the other one. So that we're drawing a shadow of this text. That's what that's doing. I would always make a function out of that. It's not that this is complicated, right? It's these little subtle changes. You might make these subtle changes in other parts of the program. You've duplicated pieces of code to do this. So you end up with this kind of extra complexity for no real reason. So you might have a function that does this little part here. Draw, shadowed message. I don't know what you call it, but who knows. So message goes, passing it through, passing it through. And the other reason why I like to do this particular kind of thing is that we can do something that this routine doesn't do. We can restore back. So what I mean is that when we call a function, I'll put that the location there actually. I'll just have Y position there, and we'll just make this a fixed offset, Y pause +4. This will just be Y pause there. Message. I'll get back to my point there in a second. So 350 was it? 350, drawing it there. Do that thing there. Oh, sorry, wrong. It's a comment character, not a comma character. There we go. So I would take that out. Even the message there too, I'd make. I refer to it as making a wrapper, and the point of that is, so we condense simple logic or repetitive little blocks of code like this into something that's safe. So when I call this, it doesn't change the state. I guess that means I can call this anywhere in my program, and it's going to draw me this centered piece. The centered message on the screen for me in this particular color in this font through, and then it's going to restore the font back to what it was after I prior to what I call it. So I can embed this anywhere I like. I don't have to worry about what comes after it or what's the state of what's happening before it. You should never have to bother yourself with those things. I know it kind of sounds like I'm picking on that, but there's lots of these little bits and pieces. As you get used to doing this stuff, you go, oh, I can make a little function that does that behavior, and that becomes part of my game's API. It's like if I want to draw a shadow, in font 1 or whatever, I might have print. I have a function called print shadowed, something like that, and then have something like that, rather. Whereas and that's been implemented behind the scenes, where I've done multiple print statements and changed the fonts and done whatever I need to do with it. But when I'm using the code throughout my program, I'm just calling this simple function to do that task. Just restore that back to what it was. The goal of that is to make all of these subservient codes simpler. Have less of these little collision problems that pop up in programs. You would not believe the number of times that modifying global state in a program causes an undesirable secondary effect. It's just crazy. Well, that's a weird one there. We're clearing the screen, all of it, and then we're drawing over everything anyway. Then we're drawing a box towards the... Yeah, and then drawing an image over the top that's transparent. Why would we do that? I tend to like, if you look at a lot of retro games at the moment, you'll find small bits of motion make the world of difference to the presentation of something, how it feels to you when you're playing it. It doesn't have to do, backflips and who knows what. Just a slight move in, a slight push, a slight shift, a slight fade. I mean, who knows what you might, decide to do. But it makes it all feel alive and active. Anyway, we'll just run that again, see if we haven't broken something stupid. Seems okay. Getting back to the game loop, let's talk about the game loop. Let's find this game loop up here. Yeah, I was looking at this loop earlier. I think that's the loop. That's the drawing loop inside the game loop. So we'll go back to the top. We'll page our way down through it. The actual method how this game works, I have no real idea. Make doors, change room, do. Yeah, this is the main loop. I don't know what that does. Change room, I have no idea. So we're entering the main loop. I assume this is the main loop. Unless it branches off somewhere else. So we're clearing the back buffer to 0, RGB 0. Doing our draw room, which is what we just looked at before. I don't know what the rest of this is doing. Sector, something. RMX is some sort of global that's carried through. WL, workload maybe? Not sure. Or work loop, I guess, maybe. Oh no, wall lasers perhaps, maybe that means. Fire laser killed. Got a huge weight in the middle of that there, but we're not actually doing anything. Right. Drawing auto sprite. Alright, so we're drawing sprites. It's a combination of drawing images and sprites. I thought it was going to be using a captured scene. I was a bit worried about that, but we're not doing that. well, just a good example there. We've got we're rendering a message. We've got all the code unrolled in place to do that. We just make a function. Make a function, have an in color supplied to it or whatever, and just be done with it. Right, so once we've drawn all the sprites, obviously the game is drawn at that point. So what's this stuff here doing? It's doing dialogues. So if we're dead, alright, if the dude's dead, do a game over loop. Well, there's one there. Repeat until joy button equals true, which means I haven't got a joystick plugged in, so if I end the game, I won't be able to continue the loop. You probably so this is one of those areas there where you shouldn't do that. In all seriousness, this creates a hard loop where now your application is sitting there running flat out for no reason. I would put like a wait in those loops. Wait a couple of milliseconds. That means the program can't max out the CPU while it's sitting there, which your iOS will just hate that in general. But all of the stuff down here is to do with messages and status bar there, for example. And so I'm assuming there's sprites here for different, like hard level effects or something like that. I don't know. I've got to wait there at the end. Yeah. That really shouldn't be there, but okay. So draw room. I'll do a quick save of that. Let's go open find declaration, I should say. Draw room. Yeah. I like you've got a header. It's nice. A draw image there, draw image there. Who knows what kind of images they actually are? So I don't know what these images are, what they're doing, and why we're drawing them. I have no idea. Some dense complexity in here, and this is what I noticed before. These texture quads. My gut feeling about this inner loop is we've got a mixture of rendering images from video memory, which I suspect these are, and these here are done with software bleeding, texture quad, which needs buffers locked and then unlocked again. If you have a loop through, you draw an image, and you think, oh, that, and your driver supports asynchronous rendering, which all in the old days they all did. They're all fantastic at this stuff. You could just pass it off into there, and your code would keep running, even though the draw hasn't even happened yet. That's what asynchronous rendering is all about. Trouble was, is if you went to try and manipulate the surface this image is being drawn onto, which is the screen, before this image is being drawn, it has to be locked and waited for, which then takes the length of that time. So there's no benefit. There's no detriment. It actually can be quite detrimental. What's all the texture quad stuff for? Stop sound 5. I wish I knew what this was doing more than what I do. Oh, that's right above where I was before. You know what I might do is I might wrap draw image for a second. What I mean, if you're not sure what I'm talking about, is I'll make a little function. Safe draw image. Whatever. I have all the same parameters. This image, and it's going to be its X position, its Y position, and its flags. Transparent flag generally. end function. Now, what I want to know is I want to know if the images being drawn in here are video or not. So I'll do a draw image. So draw image, we're just passing those parameters straight through into it. And then here, get image type, thanks. Image, sorry, this image. Don't remember the flags on the top of my head, so let's have a look at the help. Go straight to help. If it's 1, it's a video image. In other words, it's stored in GPU memory. Now you might think that means that's good. That's good if you want to do GPU level copying between on the in-video memory side, but if you ever need to do a mixture of the two, that's a real problem. It's just things have changed over time. You know, these days everything's just done with a GPU and it's done with a 3D hardware. There's no 2D hardware at all. That's why it's become so problematic for drivers. They just don't bother supporting it. All right, so if this is equal to 1, in other words, we're just putting a query in here going, are you a video image? Yeah. Like global video image count. Just a bit of debugging junk, really. So at the start of this loop, I just want to know how many of these we're doing. So safe. We probably should put parentheses around those two. User functions and internal commands have slightly different rules. It's not something I love, but it is a thing. End of that. Texture quad was in there somewhere, but a sound playing out of somewhere. Bunch there, okay. And some sprite positioning as well. So they're not being drawn, they're being positioned. That's okay. So they're being drawn in that there was a call to draw ordered sprites. So that's probably the characters. I think that would be the characters. I don't know. In text at 500, 400, and then video image, sorry, count plus string, go to the end of that thing, go to the end of that thing, yeah. Do we miss any draw images? See, texture quad, we should do the same thing there too, but I'm guessing that they'll definitely be effects images. I don't know. Just bump that. We're just embedding a bit of debug logic, just to get a bit of a sense of what's happening. If there, maybe that's a pause. A deliberate pause. Okay, that's neat. It's saying that there's no video images. So what if it's drawing in that loop and not video images to begin with, isn't it? It must be effects images. If that's the case, then anyone's familiar with, we can just lock the whole buffer. Just lock it at the start. This gives the sirens in the background, but where I live now is very, very near to a major arterial road, and there's alright. Straight away. Set the speed of the object's rotating now. It's a weird flashing with the character, but he's moving much faster. Everyone else is moving much faster too. So that's our problem. Hey, stop shooting me, dude. That's very cool. I quite like it. I bet those lines too are the same problem. So when the robot's firing out, there's it's like a weapon there too. I noticed that before. Some other ones there too. Check this out. See how it's drawing down the bottom there with a... Move over there. See when the laser's coming out? There's a shadow on the floor. I bet it's doing a blend against the video memory to do that. I suspect that probably the best way to do this game in general is to have an artificial full screen effects window, render the whole thing to the effects window, and then just do a copy down. That means that modern systems will be able to crunch that data easy as pie. You've got no driver restriction problems at all. In fact, you're not even using direct draw. It doesn't even matter from what version you've got installed. Anyway, those lines, let's assume that that's fixed that problem. Alright, draw room. More lasers. Fire laser. Last active. I wonder what that actually is. Oh, okay. We're playing a sound, regardless if it was just played. Probably should have a delay on that. But yeah, the loop's doing this. What we were just talking about before. It's drawing a bunch of lines. It's not doing a blend, it's just drawing two of them there. So let's just do, unless the ink mode's set somewhere else, then that may be the case. Oh, sorry. So we'd lock it up, lock it the start of this batch, and then unlock it at the end of the batch. Something weird there too. If we're falling, let's not do those things. Let's only do that if they're actually doing something. See how they're and running an intersection with a circle is it's not massively complicated for the runtime. If you're doing a bunch of that stuff, it all adds up, you know. So here we're doing just a pre-check to see. I think that's the falling flag, I reckon. Are we falling outside of the world, maybe? I don't know what that is there, I have no idea. But if these two cases here are not false, are both true, then we go and we check for an intersection with this circle. Whatever that circle is, I have no idea. A bunch of ellipses there as well, so lock buffer, unlock buffer, quick save again. Oh, quick save, quick run. Do a search for lines. Yeah. If you look at the shadow under the characters there, I'll bet that's alpha blended against the ground, and that does require fetching back buffer, and that's very expensive. That's cool. Before we go checking that stuff, we'll do a bit of a search for line C. Platform. I don't know what that's doing, but we'll put a lock. We'll unlock it at the end. Because each one of those locks, and there's, you know, it's 10 by 10, so 120 locks. There's two lines per. So there's 2 locks per loop. You know, even if each one of those locks takes half a millisecond, then that's a whole frame you can lose just in doing those locks. That's not the line drawing that's taking that. It's the request to the system, hey, can I draw to the buffer now, please? That's how frustrating this stuff is behind the scenes. Oh, there you go. So at one point it was actually using a camera of some sort. Wow, what the hell's that doing? I just don't know what any of this is doing. Kman, you're more than welcome to enlighten us. So many key values too, like there's certain values that represent certain things. Do a bit of a search again, find this thing. Okay. Got one line draw there. Yeah, not the end of the world. That's why we want to catch situations where we're doing a collection of brute force stuff to a surface. I think that might be the only one. Those couple of situations there, that's cool. Alright, that's fine. Let's follow this main loop again. We've tackled drawing the room. That's fine. Firing the laser. Are we killed? Are we move robots? Burn. If burn over this, then decrease life. Set a bunch of properties up in here. Wait a period of time. Delete sprite 1. That must be the player. Sprite 1. Well, there's an interesting one there. If sprite 1's the player, we're checking sprite 1. Does it exist? Has it got a? Yeah, has it got a? What images is it currently using? Is it bigger than 0? In other words, does that exist as well? It's possible if you have a sprite with no image, but it's probably some buggy behavior in old versions of PB if you do that. Copy image. So we're copying it to somewhere else. We're changing the image there. We're doing a lighting of that. if you want to change the colouring of a sprite, there is actually a draw mode to do exactly that. I probably should work out what kind of sprite settings you've got each one set up to be though before we talk about that. But this is a destructive process. We're making a copy of the image. This might be in video memory. Who knows? Making it the standard sprite, and then when you light an image, it has to read those pixels from the image. So that's why it's important that those things are not stored in video memory. If you had a secondary copy of all of the player sprites as effects images that you just use, and then you have another single sprite that's in video memory, you'd save yourself a bunch of video memory as well. So it would run on older systems, even older than what you might expect, as well as modern systems, which very few engines these days will do both. In fact, I can't think of any of them that do. We have problems with that because contemporary systems don't like legacy approaches. But you can make it work to a point where someone can sit down and play the game and have a bit of fun with it. But what I was saying is that you might have all the sprites stored in memory as effects images, and then as you need to change sprites, you don't just change the index, you copy from the current sprite required into the one in video memory. Then if you ever need to manipulate the image like this, you could do the same process but in the version that's in system memory, and then copy that down. Which means no fetching for video memory, no locking buffer problems, none of that stuff. It all goes away. There's a status bar there, a couple of shield boxes. Well, there you go. That's the same issue there, isn't it? If you try and alpha blend something with a backdrop, you've got to fetch that data from video memory to blend that down. We could have a lock around these. All of these little tweaks are not nothing. They'll help iron out the performance for not just on my system but on most systems. Because that's all we can really do is try to make it work for most people. What's bevel box? Yeah, okay. We're drawing a bunch of boxes and quads and whatever. Let's do a lock on that. Status bar, that's what it was. So we've got a lock around these. We can't do this around the text buffers, and the reason for that is I assume this is just using GDI text, which has to fetch from the back buffer as well. All the same problems exist with this, but it's reasonably optimal. But if you try and write text to a lock buffer, it'll throw up at you pretty much. So you have to put up with those. You can get around that stuff by using serif fonts, but that's another conversation. It just means reading the documentation, understanding what that means. In my experience, almost no one has ever read it and got it. So this draw image here, set font, text, drawing the score, drawing keys. I don't know what any of that stuff there is doing. Right. I think with that, understanding it's performing pretty well now. Nothing there, okay. Get out there. Whoa. I love the pinball games over there. Hey, stop killing me, dude. I think we might have to sort of leave our session there. I think we've been talking for about an hour anyway. The general problems that tend to be is this locking and unlocking buffer. You know, what kind of image are you drawing and where you're drawing it to. If you never need to do blending between things, blending it off the screen and then copying it down is always the best option. In many cases, you can actually do a lot of that work up front and then just show the resulting image afterwards. Like if you wanted to do, well, I don't know, the thing we were sort of talking about before about having the player sprites stored as effects images and then have them maybe flipped or whatever you want to do, and then maybe you want to have some sort of processing effect on them as well. You don't need to do it on all the sprites. You can just apply that to the sprites being drawn and then draw it over the top of it, and then copy that to if you need to do a video blend. My general advice is if you want to run on anything contemporary, I mean Windows 8, 10, 11, I would stay clear of video images in general, and that doesn't mean you have to you can't use both. It's perfectly fine to write a little wrapper here or there and that does that job. You know, like rather than use, where are we? There. Rather than use load image directly, for example, have a little function, that my load image, or my load game media or something like that. Have your file name, maybe your index of what slot you want to load this image into, if that's how you want to work. But then internally, you might check to see, if use video image is set to true or something like that, that would use load image. So you can kind of distill all of the logic for reading and writing media into these kind of common functions yourself, and then you don't have to maintain them out throughout the whole program. So you could use that approach to separate yourself from the behavior of the internal command sets. That's what wrappers do. Before I go, this had a very interesting idea about saving preferences. Check this out. So in order to save what's going on, saving a screenshot there as well, I think. Yeah, okay. Even this, this image is created in video memory, which means we've got heaps of lock buffers occurring on that video memory image for no real reason. This could just be an effects image, and we don't have any of those issues whatsoever. We probably should have locks around these surfaces, but I don't really care enough about that. Because I know the process of locking those buffers is not as intensive as what calling the director or lock and unlock process is. But what this does is it makes an image and then stores the data that has been of where we're up to in the game it stores it as pixel data. That's possible because these colours are just 32-bit integers. So a colour is nothing special, it's just one signed integer, a 32-bit integer. As long as this image here is 32-bit, that works perfectly well. It would only fail if you went to run this on an old system that didn't have 32-bit, only had like a 24-bit display card or 16-bit display card or 15-bit display card. In that case, this would generate, if the game's running at 15-bit, which if you request 32-bit up front and it fails, it will try 24-bit and then try 16 and 15. If they all fail, then the game's not going to run anyway. The person hasn't got a graphics card that we can even run on. If one of them's successful and it's not 32-bit, then this actually will fail. What you probably should do is there's a secondary command there called extended, which has like a bit depth as part of those. And then that would run regardless of what this creates an image that's 32-bit in system memory, and it does not matter one iota about what the current screen mode actually is. Whereas normally an effects image is the same bit depth and bit format for its RGB as the screen is. So it doesn't. So you never have to translate anything on the fly. That's the reason for that. But this is pretty cool. So it creates an image and then stores the player's data on something that you can then load into your paint package and see the data visually. Like normally with a binary file, you can't really see that stuff. Or if you have a text file, I probably would do this a bit differently here. I would have a wrapper around this. You have like a right row thing, and then just have a list of these things in order, and then so you don't have to worry about what this order actually is. So then you could reload the thing as the opposite if you wanted to. If you get what I mean. Anyway, I mean, Kman knows the ins and outs of the program. I don't. I'm just picking through and trying to make sense of what I can see. Anyway, thanks for listening to my ramble. Sorry it's so long, and we'll run the game one more time. Hopefully Kman gets some ideas about how to move forward and tackle bringing whatever changes he wants to make to the game moving forward. And it's a very impressive piece of software. It's the usage of things. It's always interesting to watch how people use the command sets that are available to them, how they favour things, how they favour other approaches. That's always interesting. Hopefully some of this has been useful. None of this is intended to be a derogatory in any way. It's just me trying to give advice as easily as I possibly can by looking at the program. I'll leave this there. Kman's done a fantastic job. Come and check out his work on progress on the forums. Check out his itch.io pages. Check out the videos we've made, etc. And give him some love. Thanks for watching, and I'll see you next time. Bye. Thanks for watching, and if you want more programming content, please subscribe to PlayBASIC.com.